So last week we talked about what things were working well, what things were not working well in terms of deciding if the shapes were similar or not. So the first question is, based on the three possible possibilities, which ones worked and which ones didn't work. So question number one says, one of the two activities, actually two of the three ideas were actually eliminated. So which ones? So you go ahead and circle them or write them on the line. And then problem number two asks you draw a quadrilateral ABCD with four sides of equal length, and then quadrilateral WXYZ has four sides again with equal length, but this time an 8. So draw the two quadrilaterals that have these lengths, but one quadrilateral isn't a dilation of the other. When you're finished, turn the video back on. So we had an activity on the day one where the sides were not parallel. That was on page 2. And the figures that had the same shape but weren't necessarily different sizes, that happened on page 3 and 4 of the day one activity. We had the rectangles on page 3, and then you were asked to do right triangles on the last page. And so right triangles, even though they have a right angle, even though they are right triangles, they don't have they're not similar shapes because one thing that continues to work is that the corresponding angles have to be the same. And so the angles in the right triangle were different than the right angle. But in the rectangle, for example, we did two rectangles that were different, as in they weren't the same shape based on the scale factors, but all the angles in the rectangles have to be 90s. So we have to be really careful when trying to decide if shapes really are similar or not. But the one thing that has always worked so far is the angle measurements have been the same. For the four sides, quadrilaterals that are all fours but yet are not similar to each other. One example would be a rhombus, which is the first shape, and the second shape being a square. So again, they are both rhombuses, but they do not share the same angle measurements, which is the one thing that continues to be true about these similar shapes. All right, so problem 3 says, so think in large or similar shapes, which means corresponding angles are the same, and the two figures have the same shape but maybe different sizes. Now I want to kind of talk a little bit about why this statement is critically true for similar shapes, even though above we just eliminated it because of what happened on the previous page and also what happened in problem 2 above. The shapes, it says same shape but different sizes. The one thing we need to add to that is that they corresponding sides have the same scale factor. So I'm going to go back to the page 2 of the activity from last week, where we had those 5 L's. And you were asked to figure out which shapes were actually similar, and the first and last shape were similar to the original shape because the scale factors were 2 and 3. So even though they all had the same shape, as in they were all L's, but they were all similar or dilations of the original shape. So as long as the corresponding sides have the same scale factor, like those 2 L's did, then we're going to, and the angles are the same, we're going to say the shapes are similar. So scale factor is really an important piece in that second part of the definition. So find a pair of corresponding sides that are given, lengths are given, and then circle the pair of lengths and what's the scale factor. And then they're asking you to see if you can figure out the other lengths based on the scale factor you've established. So if you go ahead and complete problem numbers 4 and 5, turn the video back on when you're ready to continue. So the only pair of numbers that actually we have both numbers is TK and LE. If I look at 2, for example, 2 goes down here to RG. If I look at the KN, it goes with EG. If I look at TH, it goes down here with LA, and HI goes with AR. So the only pair is TK and LE. So the scale factor, depending on how you write it, can be 2, or if I write it the other way, it can be half. And a lot depends on which direction you're going. If I am going from the larger shape to the smaller shape, the scale factor is half, because it's all the numbers are going to be half as big or half as long. But if I go from the smaller shape to the bigger shape, the scale factor is 2. So we may find ourselves going in both directions depending on the numbers we have. So TH is 3, so if I double that, that means that LA will be 6, or AL. And HI is 5, so that means AR is going to be 10, because we're doubling that. IN is 2, which means RG will be 4, because again we're doubling. And then EG is 12, and we're going actually back the other direction, so we're going to take half of the 12, so KN is going to be 6. We're skipping problems 6 and 7, and we're moving down to number 8. So we did this chapter in a different order than last year. So some of the chapter 4 review we may skip just because we have not covered those latter lessons in chapter 4. So in solving a proportion, it's something you should have done quite a bit of in both middle school and algebra 1. One way of doing this would be cross multiplication. So we take 2 tens and multiply those together. And we're going to take the 8 and the n and multiply those two together. So the left side's 100, right side's 8n. And if we divide both sides by 8, n will have a value of 12.5. Once you go ahead and look at B, C, and D, follow the same steps. Turn the video back on when you're ready to continue. All right, so in problem B, we multiply 7 to the 3, and then 5 in the x. So 7 times 3 is 21. And then we divide both sides by 5, so x ends up being 4.2. In problem C, we'll multiply the 9 and the 10. And we'll multiply the 6 and the x. So 90 is equal to 6x, and if we divide by 6, we get 15. In problem D, we're going to multiply the 2 7s, and multiply 8 and n. So 7 times 7 is 49, and then we divide both sides by 8, and we end up with 6.125, I believe. In problem E, we'll go ahead and talk about this one. I'm going to be careful when multiplying the 10, because we're multiplying the 10 to both the B and the 5. So going back to algebra, it's called the distributive property. And then we multiply the 7 times the 5. So if I complete the left side, 10 times the B is 10B, and 10 times the 5 is 50, and the right side is 35. If you go ahead and finish off this problem, and then complete the very similar steps for problem F. Turn the video back on when you're ready to continue. So we're going to subtract 50 from both sides, and we end up with negative 15. And then we're going to divide by 10, and we get negative 1.5. And in the last problem, take 9 times the b minus 1. We're going to take 6 times the 7. So again, using that distributive property, 9 times b is 9b. 9 times negative 1 is negative 9. 6 times 7 is 42. If you didn't complete this correctly, correct your mistakes, turn the video off, complete the problem again, turn the video back on when you are ready to continue. So we're going to add 9 to both sides. So 9b equals 51. We're going to divide both sides by 9, and we're going to get 5 and 2/3, or 5.6 repeating. So in problem 5, we were talking about the idea of pairing up these corresponding sides. And if I did that using a larger scale factor, all those numbers, 8 divided by 4, 6 divided by 3, 10 divided by 5, 4 divided by 2, and 12 divided by 6, they all give me a scale factor of 2. So it's really important that when we set ratios, that we're doing the ratios in the same way. So I'm going from larger to smaller, then make sure that all the ratios are completely the same way. But sometimes we can be given shapes that look similar, and we find out that in the end that they really are not. So in problem number 9, this problem appears to have two shapes that are the same. Complete the ratios using the corresponding sides. It's very similar to the problem above it. And then does every ratio have the same scale factor? So in other words, once you find those answers, do we get the same scale factor? If the answer is yes, then what is that scale factor? That's problem 9 and 10. So go ahead and complete the problem. Turn the video back on when you are finished. So 30 and 20 seem to be in the same place. The 18 and the 27 seem to be in the same place. 26 and 39 seem to be in the same place. So basically we're going clockwise. So 78 pairs up with the 52, and the 21 pairs up with the 14. So if you got the order incorrect, this is probably a good place to go back and correct the problems and then revisit your scale factor. If you take 30 divided by 20, you get 1.5. 27 divided by 18 is 1.5. 39 divided by 26, and 78 divided by 52, and 21 divided by 14, they're all 1.5s. So does every ratio have the same scale factor? And the answer is yes. And are the shapes similar? And the answer is yes, as long as the angles match up as well. So if, in other words, if I took a sheet of patty paper and if I place these two angles on top of each other and they match up, then definitely the shapes are the same. Same thing with this angle here and all the other corresponding angles. But the shapes do look like they're the same shape in terms when you look at them. But again, a sheet of patty paper would easily tell us if the shapes really are similar based on not only scale factor but also by angles. When solving a problem, I like to use the idea of circling one of the triangles or one of the shapes and then using those numbers as the denominators. I find that if you develop a strategy for doing these problems, that you can decrease your mistakes. And so these are the steps that I'm recommending. So I circled the triangle on the right, and if you look at both of the proportions here, we're solving for x and for y, you'll notice that I used the 6 twice. And the reason why I use the 6 twice is because the 6 is the only number of the only side of the 3, the triangle I circled, that actually has both numbers. So the 2.5, for example, goes to the x, and the y goes to 13. So I'm using the 12 and the 6 because I know the scale factor is 2. And so trying to pair up a set of sides that are corresponding, that have both numbers, allows me to establish a scale factor from the start. So I'm solving the 2.5, it goes with the x, so the proportion